Okay, guys. So I've started the recording and yeah, we'll start the PCD now. Okay, we'll start with the problem legs on a farm. I think that problem would have been div 3a. Devouring donuts is a very easy problem. I suppose it's only there for div 4 and it's pretty much just input two numbers and output the product of the two numbers. So we'll start off with this problem, legs on a farm. Okay. Yeah. Okay, so in this problem, what the statement is there are cows and chickens. That cows have 4 legs and chickens have 2 legs. N is guaranteed. So you need to see the minimum number of animals to get like legs in the farm. This is quite a classic problem, quite a classic greedy problem. Uh, you would have usually seen this in the form like you have you need to get like n, or the amount you need is like n, and you have coins of worth for 4 rupees and 2 rupees, and you have to find the minimum number of coins to get to this point. So you can, since like 4 is a multiple of 2, you don't need to do any DP, and you can just do greedy over here. So what you could do is, so since n is even, it is always possible. You can just greedily subtract 4 as long as it is possible. And when n reaches something below 4, you just subtract 2 and count the number of times you have added, yeah, you have subtracted from it. And that could be the output. Till, you have to subtract from it till n reaches 0. Okay. So I hope it makes sense for this problem. Okay. Does anyone have any doubts over here? Okay. Yeah. Okay, I'll explain it over here. So yeah. Uh so yeah, okay. Yeah, you need to get like to a point of like n legs over here, and you have two options. You could pick a chicken which has like 2 legs, or a cow which has 4 legs. And yeah, since 4 is a multiple of 2, what you could just do is you could yeah, since 4 is a multiple of 2, you could just greedily get subtract 4 or 2 from n up to you get n is equal to 0. And yeah, so the number of times you subtract will be the final answer you need. So you can actually do this in O of 1 too. You don't need to greedily do this like O of n times. So how you do it O of in O of 1 is you could just do the ceiling of n divided by 4. Does everyone know what a ceiling operator is? If you don't, just like unmute or tell it in the chat, I'll just tell you what it is. Okay, so I hope everyone knows what a ceiling operator is. So yeah, just an implementation detail in C++. If you do n divided by 4, it will just give you this floor of the value. So what you generally do is n plus whatever you're dividing minus 1. So here n plus 3 by 4 would give you the required output. That's what I would have done in my code too. Yeah, n plus 3 by 4. So that gives you the output over here. Okay. So yeah. Okay. So I think we can move to the next problem. Does anyone have doubts over here? Okay, I don't think anyone has. And yeah, okay, just like a bonus problem, if instead of 2 and 4, what if you had like 1, 3, and 7 over here? In that case, will this greedy strategy work? Just anyone can feel free to unmute and answer this if you want to, or just say it in the chat. 1, 3, and 7, will the greedy strategy work? Yes, yeah, we'll be thinking greedy over there. Not multiples of each other. There will be cases when it would be better to not like pick a 7 every time 7 greedily, and instead it might be better to get like 3 ones 3 over 7 sometimes. Okay, so when like there could be some cases that you could come up with, like let's say you have 9, you could either of it works, like 7 1 1 or 7 3. Okay, you got okay, so we'll move on to the next problem then, which is the next problem is maximum alternating sums. I think this was the div2a problem. So yeah, this should be, or yeah, this should be the div2a problem. So yeah, okay. Even this problem is a like is solvable with greedy. Okay, so what the problem statement says is you have like an array with n numbers in it. Okay, so yeah, just move somewhere else. So yeah, you have an array with n numbers in it. 1, comma 5, comma 8, comma 3, comma. So okay, let's say this is the array. What you need to do is you this is given to you as an input, and you can rearrange this array in any way to get array A. Okay, so you can rearrange this in any way. And find what you need is the alternating elements. The alternating elements are added up. So elements in the odd position are added up and even position are subtracted. So let's just say this is one index. So if this is the array, if this original array is the final array we are using, 1, 8, and 1 will be added up, and 5 and 3 will be subtracted from it. But since we can shuffle it up in any way, we try to find an optimal strategy. We'll try to put all the elements which are the biggest, bigger, which are maximum in the odd positions. Okay, so we'll try to greedily fill this up. Okay, so 8 is the maximum element, so we'll put it in the first position. We'll leave the second position blank for now, and we'll move to the third position. In the third position, the next maximum element over here is 5, so we'll place that over here, 5, and then I will leave the fourth position blank for now, and the fifth position, the next maximum element is 3. So yeah, we'll put 3 over here. And next, the other two elements are 1 and 1. So we'll just fill 1 and 1 over here. Okay, so yeah. Then what happens is 8, 5, and 3 are added up. So 8 plus 5 plus 3 gives us 16. And this one and this one is subtracted from our total. And the final output would be 14 over here. So the way to do this is once you input the array, what I'll just show you my code and explain what I've done over there. So yeah, once you input the array, what you do is you'll just sort the array that you're given. I've sorted it over here, and this is like probably the easiest way to do it. And first n by 2 elements. So since this floors it, it doesn't matter whether it's even or odd. And the first n by 2 elements, the first so if it's 5, the first two elements will be subtracted from the total, and the last 3 elements would be added to the total. Okay. So yeah, I hope this makes sense. If anyone has any doubt, just unmute and ask or put it in the chat. So yeah, I think no one has any doubt right now. Okay, so we'll move on to the third problem, which is yeah, powered parameters. I think this would be div2b, and yeah, it was div1a. Okay, so this was a very interesting problem. Okay, so yeah, I think a lot of people had like a O of n square strategy. I could look at it in the chat. But yeah, the O of n square will obviously not work since n is up to 2 into 10 to the power 5, and n square will go to like 4 into 10 power 10, and that would not be working. Okay, so yeah, the n square strategy would be quite obvious. Yeah, Ritik, yes, it won't work. So we'll move down. Yeah, okay. So one thing to notice, it's interesting that so we have I and j as the two positions. I'll just explain I'll just give the abridged problem statement. So what you do is you have an array with like n numbers, and you have to pick like 2 indexes, I comma j. 1 second. Pick 2 indexes I comma j. Yeah. You have AI, which is the element at the ith position, and AJ, the element at the jth position. You have to see whether AI to the power j is 1 sec. Oh, just look at the statement again. Whether it's AI to the. Yeah. Okay. So AI to the power j is less than or equal to AJ. Okay. So this is what you need to do. You need to count the number of pairs of I comma j such that this happens. There is no constraint like I needs to be less than j or anything. So I can be equal to j also. You can just consider the same position in both the indexes also. So yeah, there are no such constraints. So okay, how do you do it? The first observation to make is that to the power j, any element to the power something, except if ai is 1, any element to the power something will increase rapidly. Okay. So since aj is up to like 10 to the power 9, if ai is equal to 1, we'll just ignore the case for now and we'll come to that later. Okay. So what we'll be doing is, if ai is not equal to 1, say ai is 2, 2 to the power 30 is the maximum that could be will exceed 1e9. Do people get why this statement is? So yeah, 2 to the power 30 will exceed 10 to the power 9. So what we should possibly do is, only the first 30 indexes need to be considered. Does this make sense? Why only the first 30 indexes need to be considered? Because if we consider any element beyond that, if we power any other value to the power that element, that's obviously going to be more than aj. Okay. Except if ai is 1, of course. Yeah, Shivam, long will go to 10 to the power 18. But the thing is, the constraint has been given that the AI values are less than or equal to 1e9. So that shouldn't matter over here. What I'm telling over here is, so let's just fix like j to be one of the indexes. Okay. So yeah, for j, we need to consider only the first 30 elements could be the j index. Okay. So if j could be only from 1 to 30. Why that's the case is, if j is anything other than that, ai to the power j would exceed 1e9. Okay, irrespective of what ai is. Okay, so what you need to do for this problem is loop from the first index to the 30th index in the array. Okay, so loop from the first index to the 30th index, and so that's j. So j is equal to, one sec. Yeah, Anurag, that's a very good question. I'll just come to that later. First, we'll consider the case when a is not equal to 1. When ai is equal to 1, j could be any of the values. Okay, first we are just considering a case where j is ai is not equal to 1. Okay, so if a is equal to 1, j could be even 1e5. It shouldn't matter over there. So yeah, we'll loop j from yeah. If ai is 1, for that j could be anything. So it shouldn't matter. So yeah. Yes, true. That's correct. Okay. For j, we loop it from 1 to 30. 1 to min of n comma 30, but that's just an implementation detail. Okay, so we'll loop from 1 to 30, and yeah, for j from 1 to 30, and I will loop from 1 to n, and for each ai, we'll exponentiate ai by j and check whether that is less than or equal to aj. If this is the case, we'll add 1 to the total value. Okay, so does this make sense so far? Just if someone has any doubts at this point, like just unmute and ask in the chat. I hope it makes sense so far. No one has asked any doubts. Okay, so yeah, cool. Yeah, so yeah, this would pass since it's 30 into n. Okay, so that's the reason it passes. Yes, Pratik. Okay, so yeah, it seems to make sense so far. Okay, so another thing to consider is, what if ai is 1? Okay, if ai is 1, j could be anything. So in that case, you just add you just leave a loop from I from 1 to n, And if AI is equal to 1, just add n to the total. So the reason behind this is j could be anything. So since aj is also greater than or equal to 1, if j is, even if j is 10 to the power 5, 1 to the power 10 to the power 5 is still 1, and any number is like any number will be greater than or equal to 1 in the input. That's a constraint given. No number is 0, so that doesn't matter. Okay. Yes, I kept total as a long. Yeah, total should be a long. That it's quite possible that it would exceed. Okay, one sec. Wait, will it exceed? Yeah, it would exceed if all the numbers are 1. If all of everything is 1, it will go up to n into n, and that would obviously exceed. Okay. So yeah. Okay, so I'll just show my implementation and just cover up some implementation details about how this is done. So yeah, you loop from 30 to n, and I'm just checking if vec j, the element is not equal to 1 over here when doing this check, and I'm powering up till yeah, I'm powering it till c, and if it exceeds v at any point, I'm returning false. Okay. So I don't think if you don't have this statement over here and have it over here, it will have like long exceeds, because suppose this is 1e9 and you're powering it to like, suppose x is like 10 to the power 9 and you're doing like power 5 or something, that will exceed. So you have to break it immediately if it exceeds v. Okay, you have to have this inside the loop. So yeah, I'll share the implementation links after the PCD. You guys can go through it. Okay. Yeah, Shivam, you have to add 1 for if array is equal to 1, you have to add in any case. And while inside this, when you're looping from 30 up to 30, you only like if the element is equal to 1, you skip that element and move on. Okay. So yeah. Does this so I hope this problem makes sense. If anyone has any doubts, feel free to unmute and ask, right? Or I can move on to the next problem. So yeah, I think I can move on to the next one. Yeah, okay, cool. So yeah, what's the next one? The next one is the problem. Yeah, ABC conjecture is the next one. Too far for comfort has 2 versions. I'll deal with them both at once at the end. Okay. Okay. So what does this problem state as? I'll just explain the problem quickly. Okay, someone has sent code in the chat. One sec. Okay, what is the code? Okay, what was the verdict you got, Anurag, for this code that you sent in the chat? Okay, then it should be right. What have you done? Okay, it's usually not recommended to use that log2i functions and all these things. 2 pointers, Shivam. Like, I'm not sure if, wait, I'm not able to think of an approach right now with 2. Okay, did you like sort the array and try 2 pointers? Like, sort it and do something with that? Okay, feel free to unmute and like explain your approach. Like, I'll just try to. Oh, you mean for the next problem? Okay. I mean, I thought you were talking about the previous one. Anurag has sent the code for the thing. Okay, cool. I'll come to that in a second. I'll just look at what Anurag is wanting over there. What have you done, by the way, Anurag? Like, can you like unmute yourself and just explain your code? It might take a long time if I have to go through the code.
Hello.
Yeah, I can hear you. Yes.
Sir, I observed that uh, as we can see that uh, a of I to the power j should be smaller than equal to aj.
Yeah.
So taking log base to both the sides, we
Yeah.
can get the equation as j log 2 a of I is smaller than equal to log 2 a of j. So we can transpose j here and in this way I have implemented it.
Okay, cool. That's a nice idea. Okay, that's a cool idea. But the only problem that could possibly happen over here is like precision issues because you're using the log2 function and all that, but that's a nice idea. Like that should work. That makes sense. Yeah. So you binary search for it and find the, yeah, okay, cool. Yeah, makes sense. Okay, so we'll move on to the next problem now. The next problem is the ABC conjecture problem. So yeah, there was one more message. Okay, cool. Brad Hawk. Okay, that was the first idea that I had when I immediately looked at the problem, but I'll explain why that will not work in a minute, okay, when I'm explaining the solution. Yeah, that was the first idea I had. Okay, Brad Hawk. Like the when I okay, so basically what the problem states is you have a string, let's say A, B, the characters in the string are A, B, and C. Okay, so let's say this is the string, and you have you have to find the three indexes I, comma J, comma K, such that AI, AJ, and AK form A, B, C. Okay, so and the constraint is that AI is less than J is less than K. Okay, so yeah. And yeah, so it's a ABC should be a subsequence. You find such a subsequence, and you can either remove A or you can remove C. You can do either of it in one operation. Okay. No, not exactly a monotonic function. I'll explain it. Okay, 1 second. Okay. So yeah. Uh, okay, that's sad. A lot of wrong answers. Okay. Uh, you can remove either of A or C, and you have to find a way such that the number of operations that you perform is minimized. Okay, so you have to perform operations still it is possible, and you have to find a way such that the uh, you reach the point where no such operation is possible fastest. Okay, so what do you need for this? What is the condition you need for it? There are for every B present in the string, there should be no A to the left of it or no C to the right of it. Okay, so either of these conditions need to be fulfilled. Okay, so yeah, does everyone understand the problem statement, like what we are supposed to do and all this stuff? And I hope everyone did. Okay, yeah, okay, cool. So yeah. So you have to check for this B and this B. Both the B's need to be considered. Okay. So what you would want to do for this problem is there are two options. Okay, there are multiple options. What you need is suppose that for this B there should be no there are two like there should either be no A's to the left or no C's to the right. And for this B there should be no A to the left and no C to the right. Both these conditions need to be fulfilled. Okay, that's what you need to ensure when you do it. So what you'd want to do over here is for each B you'd want to see two things. Number of 1 second. Yeah, for there are okay, the two base cases that many people considered over here is that for the first B you try to remove from this you'll try to remove all the C's present to the right. Okay, that's what you guys try to do, right? All the C's present to the right, or from the last B find all the A's present to the left. This is a quick, like, greedy strategy that most people, yeah, min of both. You try to find this and find the min of both. Okay, why doesn't this work? The reason why this wouldn't work is, one sec, I'll try to create a counter example right now. A, 1 sec, I'll just try to think of a counter example. Okay, what would be the output of your code in this case? Can one of you just send it in the chat? Like, yeah, it would be 4. Do you see what the problem is right now? Is there a better way to do it without 4? Yeah, the answer should be 2. Yes, correct, Shivam. So what you could possibly do is you could remove this A and this C. That way, B, C, 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 A. For this B, there is no A to the left of it. And for this B, there is no C to the left. Sorry, for this B, there's no, yeah, that's correct. For this B, there's no A to the left of it. And for this B, there is no C to the left of right of it. So that way, you couldn't possibly, with only this substring, you can't possibly form any valid solution. So what do you do in this case? What you do is, for each B, you see how many A's are there to the left of it, okay? And you also see for each B, what? What did you do, by the way? Like min of Brad Hawk, what did you do? Like min of left and min of right? Okay, you saw how many A's are there at the left of the min. Can you just explain what you did quickly? I'll try to comprehend what. Oh no, I can't look at the code. Looking at the code will take up a lot of time. Can you just like unmute and explain or?
Hello. Am I audible?
Yeah, I am. You're audible. Yes.
Yes, for every index where the character is B,
Yeah.
I looked at the left prefix where I stored the count of A characters,
Yeah.
and in the suffix of C, I stored how many times C is coming in the right side of index B.
Okay. You are very
Yes,
close. So you try to find the minimum of this.
yes. For every index, I'm finding that if my left side is minimum or right side is minimum.
Okay. But the problem is in this thing, suppose you're doing this, okay? Oh, for each index, you're seeing which side is minimum
Yes,
and
yes. But one condition is extra, like if I find the right side is minimum, then I won't go further, like I will break the loop because I have taken all the C's and it's better to break the loop.
one second.
Like if I find the number of C's on the right is less than the number of A's on the left,
Yeah, okay.
then
So
I will break the loop because I took the minimum C's and if I remove all the C's, then then there is no case I will find ABC.
yeah, okay. So makes sense. Like, but I think like you can generate a counter case for it. Okay. So like one sec. Let's see. One sec. Let me just think of what. Okay. So suppose this is the test case. What would your solution output?
For this test case, like for index B, I will see the minimum of A or C, it will give 1, okay. Then
Yeah.
I will go to index B.
Yeah.
Then I will see left side S and C. Already I have took 1 as prefix of first B.
Yeah.
So I will minus the prefix of current prefix and the previous prefix. So it will give me 0. So 1 plus 0, it will be 1.
Yeah. Okay. So for this case, it will work. I'll try to think of a counter case. Okay. Now I'm not able to think of one quickly. I'll like after the PCD or something, I'll just try to think of it and send it over Discord. Okay. But that is a
Okay. No problem.
no, I think in this, can you look at the chat? Unknown boy has sent a case. Brad Hawk, can you?
Yes, I'm looking at it.
Yeah, but I think it will give 2 for that. Okay, I'll just like, yeah, look at it. I'll try to think of a counter case quickly, but before that, I'll just explain what my solution was. Okay, so okay, let's just go to the previous thing, whatever we had. Yeah, okay. So this was the string we had. Okay, so this string has like 4 C's and 3 A's in the middle, and it will not be optimal to remove all of them. So what you do is, for this, for every B, you find the number of A's to the left of it, and for the next B, okay, not this B, but for the next B, you find the number of C's to the right of it. Okay, and you add the count and this count, and you find the yeah, okay, for that case it will give to Brad Hawk, it will be correct. Okay, so yeah, okay, as I was saying, you'll find the number of A's to the left of every B, and for the B right next to it, okay, the B immediately next to it, you'll find the number of C's to the right of it, and you'll add these two, number of A's to the left of this B and number of C's to the right of this B, and you'll find the minimum of this for every such pair of B's, okay, every such pair of B's where these two B's are adjacent. Does this make sense, like what we are doing over here? Okay, so yeah, this should work in this case, because here we take what? Okay, what about the C's in between of them? What would happen is, what we are doing over here is, this A we'll be considering over here, and this C we'll be considering over here. So if we remove these two, that would be enough. Okay, so these C's, even if we don't remove these C's, we wouldn't be able to form a proper ABC subsequence with this B. And similarly, since this C is that, there won't be any C following this, and we won't be able to form a proper ABC subsequence with that. Okay, does that make sense? Shivam and Parishi had asked it, and so does that make sense? Yeah, okay, cool. Shivam, Parishi, did that make sense? Okay, cool. I hope it made sense. Okay, okay, cool. So that's basically what you do, and along with this, you'll also have to consider the case that you guys told at the beginning. So for the last B, you just see whether you'll try to remove all the A's before it, and for the first B, you'll try to remove all the C's before it. That will also be considered, and the minimum of all these values will be taken for the final output. Okay, so does that make sense, guys? This is the solution to this problem. Okay, what if there are multiple, one second. Yeah, if there is only one B in the string, what you do is, the only case you'd have to consider is the, like the cases you guys had considered initially, like remove all the A's before this, and remove all the C's after it. One second, can't we, for which case? For the case of Lakshya, which case are you talking about? One second, I'll showcase the code in a second, and someone else that has another doubt too. Noob has another doubt. What if there are multiple B in between? So, okay, what if there are multiple B in between? What you're doing is, what do you mean by, like, we'll be considering all pairs of adjacent B's, Noob. So what will happen is, if there is another B in between, we'd consider this two as one set and this two as one set. We wouldn't need one O of n square combination. We just need for each adjacent pair of B's. Okay, how do we come up with the solution? Okay, I'll just like try to complete the solution and address unknown boy. Okay, cool. Noob, does this make sense? Like what I just told? Noob. Noob, are you there? Like, if you have any other doubt, feel free to unmute and ask. Like, if we have multiple B's in between, we'll be considering each pair. Okay, till Noob comes back, or yeah, okay. Yeah. Yeah. Lakshya, in this case, we'd be removing the first A and the last C. That's what we'd be doing with this checking. So for this B, you'll get like the number of A's before that will be 1, and the number of C's after that will be 1. And so you do this 1 plus 1, and that will give us the answer to be 2. Okay. Does that make sense, Lakshya? Or does that make sense? Guys, reply in the chat. Yeah, okay, cool. Nice. I'll just show the code. Shivam Taneja was asking about the code. I'll just share it up once again. This is the one, right? Yeah. Okay. Okay, how do we code this up is for each thing, what I'm doing is I'm like doing a prefix sum of the number of A's, okay, up to each index. Okay, that's what PRA is storing, and the suffix sum of number of C's. I've got another message in the chat. Okay, cool. I'll zoom in a little bit, and yeah, okay, 1 second, I'll do that. The code, you mean? You want me to zoom in the code? Is it better now? Yeah, okay, cool. You want me to zoom in more? Brad Fox says more, or I'll just open it in Sublime and show it. Yeah, okay. Is this visible? Yeah, okay, cool. So yeah, basically what you're doing is, so you're taking the prefix sum of someone else. Yeah, Kevin, I'll try to explain it with one more case after explaining the code, Kevin. Okay. So yeah, you're taking the prefix sum of all the A's over here, PRA. So up to index I, how many A's are there up to this position? And SFC stores how many C's are there up to the ith position, suffix sum of how many C's up to the ith position. Okay. So then what you're doing is you're storing the positions of all the B indexes with B in that position in the variable B plus. And this is basically what you guys did. For the last B, you're seeing the number of A's before that and the number of C's after the first C, and the minimum of that I'm storing in the MI variable. Okay, I'm storing that over here, and I'm looping from the first B position till the B position before the last one. I'm not including the last one because if we include that one, we'd also need a extra one which follows that, and that won't be there in the array. We only have like if there are like 5 B position, we'll consider only till the fourth one, and the fifth one will be paired up with the fourth one while checking. Okay, so yeah. Then what you do is you'll find the minimum of MI, the previously stored MI, and the prefix till this B position, prefix of the A till this B position, and the suffix of the C's till the B position of the till the next B position. Okay. So does that make sense? Does what I'm doing over here make sense? If there are any, if anything is not clear, just feel free to ask in the chat. Okay, cool. You mean this loop, right? The for this thing. Okay, so what I'm doing over here is you're looping till okay, B push stores all the positions of the B's. Okay, you're looping through each of the positions of the B's. So as I explained while explaining the approach, you need to consider one B plus one B and the B right next to it, the adjacent B. Okay, so you're considering this B and the next B. And for this B, you're finding the number of A's before it. That's stored in the prefix. So this is the prefix sum of the A's, and that stores the number of A's before this B. And the suffix sum of so you have and another thing you have to find is the number of C's to the right of the next B. Okay, so SFC stores the suffix sum of all the C's after this. This covers all. 1 second, I'll just okay. So this covers all pairs of like adjacent B's, right, Shivam? Like we only need to consider like adjacent pairs, right? We don't need to consider pairs which are like far away from the other things. We only need to consider the adjacent ones. So since we're looping through all the B's, yeah, okay. Oh, you mean that way? Okay, I kind of get what you're saying. So why is it enough to consider the minimum of only one pair? Okay, I'll just explain what Shivam is asking. Okay, what Shivam is asking is when we are doing it, are we not considering only the minimum of one pair of okay, this is what Shivam was asking. Over here, if you're taking, say this is the minimum, I've not solved like what the answer would be for this, but let's just assume when we're taking this and this, that gives us the minimum answer. Okay. In that case, what are we doing? We are removing all the A's to the left of this B. Okay. And we are also removing all the C's to the right of this B. Okay. So both of these are added up. And when we are considering these two B's, we are removing all of those. So even for this B, what happens is these two C's are also removed. Either these two C's are removed since this is after this. So these two C's will anyways be removed. If we have another BA over there, we'll be removing this A also along with this. And for this B, there will be no A to the left of this. Okay, so I hope that Shivam, that made sense. Okay, cool. Okay, cool. So Lakshya has asked an idea. What is it? Let's suppose for any random test case, every time there is B or consecutive B's, can't we like add minimum of A's on the left of it and C's on the right of it and turn them to, let's say, okay, I think what you're describing is very similar to what I've done over here. Like, can you unmute and explain, or just say, well, how is it different from what I've done over here, Lakshya? It feels very similar. Okay, cool. Like I can't think of only one right now. I don't know if there is any easier one. Like this is like a problem with solution which is right to this level. Okay, like I think this is the easiest way to do this. I'm not sure. Like maybe after the editorial comes out, I'll check whether they have some other different approach. Okay, okay, Lakshya. Like maybe we'll just asking how will this. Okay, how will this work? Like how this works is like I explained for this case, right? Since we are having adjacent B's, if we are removing all the A's to the left, it will also make sure that if there are any other B's to the left of this B, for that also there won't be any A which is active after that. Okay, so that case would be considered any B to the left of it. For that there will not be any like any A's to the left of it. And suppose there is a B to the right of the second B. For that, we'll make sure that there is no C which is present after that. Okay, Lakshya. So does that make sense, or is there any issue with that? What I explained? So we'll be removing all these C's when we are taking that up. If that wasn't clear. Okay, cool. Yeah, feel free to, yes. Yeah, okay, feel free to. Should I just answer Lakshya's doubt first and come back to your Shivam? I'll just answer that. Yeah, okay. So, okay, let's just take. Okay, let me try to quickly. I think the answer for this would be you'd pick this and this B as adjacent ones, and the answer would be 3 plus 2. Answer would be 5. I think I'm not verified with everything, but I think the answer should be 5. Okay, so yeah, that should be the answer. So why is the answer? So how does this work? What you do is for this B, you are seeing the number of A's to the left of it. Okay. So there are 3 A's to the left of it for this B. And the next B is this one. All these are just C's and A's. So the next B you would have to consider is this B. Okay. For that, the suffix in for that B is this C. There are 2 C's to the suffix. So 3 A's and 2 C's. That should be the minimum, I think, because for this B, there would be all these extra A's, and for this, yeah. So that should be the minimum, I guess. And so the answer would be 5. So why is this correct? Why is this correct is, suppose for this B, there will be no such, no A that you could find in the left of this B. Since when you are removing all the A's to the left of this B, all the A's which are to the left of this B will also be removed, okay? So does that make sense so far, Lakshya? I hope it makes sense. And similarly, when you're removing all the C's to the right of this B, these two, the C to the right of this B will also be removed. So for this B also, you wouldn't be able to solve form any proper subsequence. Okay. So does that make sense? Does it make sense about why? Okay, cool, Lakshya. About implementing it, I had already explained the implementation. So yeah, so no, what we are doing is we are adding the number of A's to the left of this B and the number of C's to the left of this B's, and we are finding the minimum of this for every pair of two B's. Okay. What is Brad? Oh, okay. Perfect. Brad Hawk, can you please like not access the screen? I think you've typed out the link over there.
You can turn this off from security.
What?
I guess.
One second.
Click on the security button on top.
Where is it? Button or
Left.
well, okay, this one. Yeah,
Near start video button.
okay, once again. Oh, you mean in Zoom?
Yeah.
Okay, once again. This is.
No. There's
Oh, this thing.
yeah, a little left.
Okay. Yeah, this.
No. Near participants.
Yeah, okay, second. Oh, this, okay, sorry. So what do you do? Annotate. Which one should I do?
You can turn off the annotate option.
Okay, one second.
Yeah, and go to annotate and clear. You can clear this one.
Okay, one second.
Right. There's annotate button on. Yeah, here.
More.
No, right to post share.
Okay.
Yeah. You can clear everything from here.
Yeah. Yeah, okay, cool. Yeah, okay, we'll continue then. Were there some doubts in the chat? 1 second. Every time we need middle adjacent B. What do you mean, Ritik? Like, I don't. We can pick any. We have to check for every pair of adjacent B's. Okay, so that will be O of n B's. So we'll be checking for every pair of adjacent B's. But okay, no, what is he asking? ABC. Then for this, it will be 2 right answer, but should be 1. What do you mean? Like, okay. Okay. For that, what you do is, in my code, when I was explaining the code, I also included the case where for the B, for the last B, you'll try to see whether, or whatever you guys did. For the last B, you'll try to remove all the A's before that. And for the first B, you'll try to remove all the C's after that. So both of those will also be considered for the minimum. Okay, that's what will happen. No, does that make sense? Okay. Okay, cool. So I hope that made sense. No, okay. So does this make sense, everyone? Should I move to the next problem, or is there any other doubts? Feel free to ask it now, or I'll move it. You want another test case? Brad Hawk. This was another test case that I gave. What? Yeah, sure. Yeah, Shivam. Yes, unmute and ask.
Yeah, so my doubt was, how do we know that it's optimal to take the pair of B's? Like, what if like only one pair of B? How do we know that's the optimal answer? What if there are multiple pairs of B's where we could, sort of take out one A from the one and the one C from the other, and then sort of get an answer?
Okay, so we are considering every pair of adjacent B's, right? Like, I'm not.
Yeah.
Yeah. In that case, for this B, we'll check for every pair of adjacent B's, the sum of the A's before that and the sum of the C's before that, and we'll add them up and see the minimum. So we'll be checking for every B's, right? So what's like, You mean for case that you're taking this B and this B. That's what you.
No, no, that's what I'm saying. That's not what I'm saying.
Yeah.
I'm saying, how do we know that the most optimal answer is taking the minimum of sum of only one pair of Bs? Why can't it be sum of multiple pair of Bs,
Yeah.
wherein somehow we get like a case where it's, it's better to take all of them.
The thing is, if you take with like if you so what do you mean, like for this B and this B we are taking the number of A's
Let's say there's a case where there are, let's say, two Bs at the start, two Bs at the end,
yeah.
right? And there is one B, like it's a very long string, imagine that, and there are two Bs in the middle of the string. How do we know that the sum of the end Bs at the ends,
Yeah.
like the sum of the prefix and suffix of Bs at the ends, is not better than the sum of Bs in the middle?
Okay, so you mean let's say we have a long string thing, and for this we'll take the some A's from here and the C from this side, and for this we'll take some A's from this side and some C's from this middle. That's what you mean, right? And we
Yeah, just randomly taking out Bs. How will we know that the random Bs won't give us a better answer than just taking it for two Bs?
Okay, the problem with that is this would like not work in some cases. Okay, this would what would happen over there is suppose you have two B's over here, and you mean like you take all the but in any way, if you're taking the B A's to the left of this, you have to take all these A's, right? So you have to remove all these A's, and for this B, you have to remove all the C's. Okay, but anyways, when you're removing the C's to the left of this B, we'd be removing all those including that anyways. Okay, so why would you want to add this up again? Does that make sense?
Right, yeah, makes sense. Yeah, I'm sort of getting why. Yeah,
Okay, it's fine. That's valid.
thanks.
Okay. Okay, so I think we can move on to the next problem. I don't think, is there any other doubts or what is this? Yeah, it includes everything. Okay, so should we move on to the next one? Okay, next one is a slightly heavier problem. We'll move on to the next one. So what is it? Did anyone manage to solve this? Okay, so basically what the statement is this. Did you guys read the statement, by the way? Like, can even yeah. I don't think anyone read the statement. Okay, so I'll try to explain the statement too quickly. Okay, so the statement is a bit complicated too. So you have your you need to construct an array A. Okay, you need to construct an array A of length one sec, of length n. Actually, the integer n is given to you, and you need to construct an array of length n. What you'd want is and let's say SA is the set of elements in A. Okay, all the elements in A like only occurs once. Okay, so SA is a set of all the elements in A. What you want to see is for let's say if for each prefix of A. Okay, one second, I'll just go to the whiteboard and explain it. So yeah, let's say this is the array 5, 4, 2, 2, 4, and yeah, let's say this is the array. Okay. So this is the array, and what you want to see is for each prefix of this array, you would want the number of occurrences of any element x, is in this array, the number of occurrences of that minus the number of occurrences of any other element y. So f of x represents the number of times x occurs up to the ith index. Okay, that's what f of x represents. And you want to see f of x up to the ith index minus f of x f of y up to the ith index, where x and y are two elements that occur in this. Okay, one sec. Yeah, x and y are two elements that occur in this. The absolute value of this difference is less than or equal to 1. This is what you need to see. Okay, does this make sense what we are doing up to here? Does the notation make sense? If it doesn't, I'll explain again. Just say yes or no on the chat. Okay, seems like no, everyone has understood that. We'll Okay. So yeah. So that's what you need. So the frequency of x up to the ith index minus the frequency of y up to the ith index needs to be less than or equal to 1 for every index in this array. Okay, that's basically what you need. And to do and you need to so you're given two numbers n comma n m in the input. What you need to do is you need to construct an array of length n such that each element is in the range 1 to m. Okay, each element is between 1 and m, and this condition is satisfied for every prefix. Okay, this condition is satisfied for every prefix. Do you guys understand the problem statement, by the way? If you guys didn't understand, feel free to unmute and say it. Just say yes in the chat if you understand it. Okay, did you guys understand it? Yeah, okay, cool. Soumya has understood it. Okay, cool. Then I'll start with the explanation about it. Yeah. Okay. What you need to observe is suppose you have an array like this. 1, 2. So far the suppose n is equal to, let's say n is equal to 5. And m is equal to 6. Okay, this is the test case given to us. Okay. So you'll have suppose you currently have one. What you need to do is you need to construct arrays of length n that each element is between 1 and m. And yeah, this condition is satisfied. Okay, the frequency of x up to the each prefix minus the frequency of y up to each prefix is less than or equal to 1. That's the condition you need to satisfy. Okay, so yeah, how do you do it? What you need to observe is suppose you have 1, 2 and you add another 2 over here. Okay, after this point you cannot add another new element over here. You can't add say 3 or 4 or something over here. Why can't you add anything like that? So the reason why you can't add anything like that is up to this point 2 has been repeated. Okay, 2 has repeated twice and the number of occurrences of 2 is 2. Okay, so then up to this point the number of occurrences of 3 or 4 is 0. Okay, so if you do f of so it's up to the index 3. We'll just do one index. Okay, one index array. F of 3 of 2 minus f of 3 is equal to 2 in this case, which is greater than 1. Okay, so this won't be valid. So one observation to make over that here is if an element has occurred twice so far, any element in the array has occurred twice, no new element can be added to the array. Okay, this is the first observation to make. Okay, once you make this observation, another thing that you can quickly observe is suppose you have 1, 2. Suppose you have 1, 2, 3. Okay, then suppose you have the next element to be 2, and after that you have a 3 over here. Then you can't have and 3 again over here before having a 1. Okay, why can't you have a 3 again over here before having a 1? Then the reason behind that is if you do f of 3 minus f of 1 up to this point, if you have a 3 over here, then that would be 2 and that would be greater than 1, and that would violate the condition that was mentioned previously. So over here it should be a 1 for sure. Okay, that's a necessity. Okay, and again the same thing would be repeated when it can be a 3 over here. And since 3 has occurred thrice, you can't have a 3 again over here before having 2 and 1. Okay, so it has to be 1, 2 and so on. So the thing to notice is suppose you have 3 elements in this array. The 3 can be anything: 1, 2, 3, 4, 3, 6, anything up to such that the elements are less than or equal to m. So suppose you have like 3 unique elements in them. The array should be filled with continuous sets of permutations of these numbers. So what are permutations? These numbers can be ordered in n factorial ways. So the array should be filled with n factorial ways of this number. Okay, that's basically what you need over here. So 4, 3, 6 can be like put around in like 3 factorial ways, and 1, 2 can be put around in like 2 factorial ways, and so on. Okay, those are the so the array needs to be filled with permutations. That's the most important observation to make in this problem. Okay. Does it make sense so far why the array needs to be filled with permutations? Guys. Yeah, I hope it made sense. Okay, so that's the first thing. The array needs to be filled with permutations. That's the first observation. So how do you do it? There are suppose you have like you can fill it with m elements. You have options of picking like the array could be set filled up with permutations of length 1, length 2, length 3, up to length min n comma m. Okay, so the array could be a permutation with like up to any number of elements up to min of n comma m. That could be the length of each permutation. So here the length of one permutation is 3. And if the array is of length n, there would be 3 permutations, 3 such distinct sets of permutations. Okay. So that's basically what would be the thing. And yeah. Yeah. Yeah, this is quite like it is solvable, but it's quite a complex problem. The one thing is I don't think you guys have read the statement before, and the statement is quite hard to understand in itself. Once you get it and like you get this observation, this should be solvable. Like this is a critical observation to make. And if you come to this observation from this from the thing I explained over here, that you understood the problem, right? So Brad Hawk, did you understand till this point what I've explained till this point? If you have any doubts still here, feel free to ask. Okay, so that was like okay. So okay, just so now like just take this for now. Okay, how to think like you. That's just practice. I've been practicing for like a year or so. Okay, that's basically the thing. So you just need like permutations. Okay, that's the thing so far. So you can pick any 3 elements up to 1 to any like for each I from 1 to m. Okay, for each I from 1 to m, permutations of length I. Okay, so you need permutations of length I, and you fill the array with some number of permutations of length I. That's basically what you need. Okay, one sec. That's what you need for this. And yeah, where is that problem? Where is it? This is not the one. Okay, cool. So yeah, okay. Now what I'll just explain this with my code that would make like what I'm doing after this. So just okay. Now you would understand like 50 I don't think so today. Like, okay, whenever I do CC, I don't do CC that much actually. I just did it today because like I had to do the PCD. Okay, cool. So where is the problem? It's problem C. Okay. So, okay, let's just take it for now that you need to fill the array with permutations. So I'm inputting n and m over here, and total is the final output variable. And what I'm doing here is for each I from min of n comma m plus 1. Okay, for each I from min of n comma m plus 1, what I'd be doing is out is equal like so what I'm doing is the array is filled with permutations of length I. Okay, each so length permutations of length I. So I could be 1. In that case, the array would be this one. The array would just be 1, 1, 1, 1, and 1 if I is equal to 1. Okay, if I is equal to 2, the array could be filled. This would be one such way to fill the array if I is equal to 2. Okay, if I is equal to 3, there are Similarly, you'll have other ways to fill the array. So what I'm doing here is I'm looping from I from min n comma 1. I is the number of distinct elements in the array. Okay. So the num okay, cool. So the number of permutations that you'll fill the array with is n by I. So n by I is it's a floor of n by I. So since I elements, there could be n by I separate permutations in the array. Okay. So yeah, n divided by I will give the number of permutations, but this will only give the number of like whole permutations. If it's 9, it will give 9, and I is equal, the n is equal to 9 and I is equal to 3. This will give 3 because you could do 1, 2, 3, 1, 2, 3, 1, 2, 3, 3 times in that array with n elements. Okay. So yeah, factorial of I. So if you have n elements and you want to find the number of ways to like factorial that element, what you'd have is factorial of I. Okay, number of ways to like arrange those elements. You'll have to do factorial of I. So out would be factorial of I to the power n by I. So what this is this? So for each permutation, you'll have like factorial of I ways to arrange it. Okay, and since there are n by I permutations, you'll be multiplying factorial of I n by times with the same thing, factorial of I into factorial of I into factorial of I n by I times, and I'm using binary exponentation for it. So I think binary exponentation would have been covered for like level 3 people. I'm not sure about the exact structure. So like you use binary exponentation to compute this value, factorial of I to the power n by I. I think the intuition would be quite hard to capture. Okay. Yeah. Okay. So okay, binary explanation. Nice. Okay. So what you'd be doing is, suppose you have so you're considering a permutation with I distinct elements. The number of ways to arrange that permutation is factorial of I. That's like basic permutations and combinations. So yeah, factorial of I would be the number of ways to do it. Since there are n by I such permutations in this thing, and each of them can be arranged in factorial of I in different ways, you will just multiply factorial of I with itself n by I times. So for that, you're using binary experimentation over there. Okay. Then there's one more step to do over here. If I is equal to 3 and n is equal to 9, you'll have n divides I perfectly, and you'll have like 3 perfect sets. Okay, one second. Yeah, feel free to ask that after this explanation, that talk. Okay. So yeah, you'll have like 3 separate sets of factor. You'll do that. But okay, for n is equal to 9 and I is equal to 3, you'll have 3 distinct sets. And see, but say n is equal to 10, you'll have 1 remaining. Okay. So to deal with that, what I'm doing is C is equal to n mod I, and you'll have like you need to you need to pick only C of the elements. Okay. For that, this is basically like I think in grade 11 in high school, you'll have like something in permutations, you'll have like NPR or something. So with n elements, you need to pick R of them and fill that in like the number of ways to fill them in distinct ways. So this is basically that over there. Okay. NPR is what you're computing over here. From the I elements that you're picking, you only need to pick C elements for the last, like the remaining thing. So suppose 10, you have 10 and I is equal to 3, only 1 would be remaining. So in that case, you would need this. And yeah, and what you do is out is equal. So this would be the thing. And finally, what you're doing is, since you have like from the m elements, you're picking only 3. Okay, the 3, suppose m is equal to 5, what you're picking could be 1, 2, 3, or 2, 3, 5, or 3, 4, 5, or anything. And yeah, Brad Hawk, that makes sense. Okay, so from m, you'll be picking 3 elements. And yeah, so for that, you need combination of m choose 3. Okay, MC3 is what you need. Okay. Yeah, that's where, so that you're multiplying with this out, and yeah, then you're getting the output for that. Okay. Then you're adding that to the total, and for each I will be doing it. Okay. I think I don't think anyone has followed it so far. Okay. Okay, I'll try to explain the pseudo code in the whiteboard, but I think just like, okay, cool. Okay, so this pseudocode, I'll try to explain it. So basically what you're doing is you're looping for from I, you're looping from 1 to min of n comma m. Okay, that's what you're looping. One sec, I'll just erase this. Okay, I'm not sure if I'll be able to do everything. Okay, you're looping I from min of n comma m. Okay, so that's basically you're doing. What I is the number of distinct elements you're picking. Okay, so that would be the permutation size. Okay, so let's just create a variable out. That out would be this temporary variable for this iteration of the loop. That would be factorial of I, factorial of I to the power n by I. Okay, so this n by I is floor. Okay, floor of n by I, because that would be that number of distinct permutations, distinct permutations. And yeah, okay, so that would be what you'll store in out. Okay, then what you'd have next is one sec. Yeah, okay, so this would be the number of ways to have the distinct permutations, number of, like, so if n is equal to 9 and I is equal to 3, this will just work out perfectly. This will give a perfect thing, and there will be 3 complete permutations. But say n is equal to 10. In that case, there will be one permutation which is not complete. Okay, so you'd have 3 complete permutations, and that would be taken care of this part. But there would not be one permutation will not be complete. Okay, so for that, what you're doing is C is equal to n mod 3. Okay, this will give the size of the permutation which is not complete. Okay, so you get C is equal to 1 over here. C is equal to 1. And what you need is these I elements, those can be set up in all of these C positions. Okay, the number of, so those need to be permutated in those C positions. So what is that? I T C. Okay. What is 1696? I'm not getting you over there. And IPC will be what you'd have over here. Okay. So what IPC would give you? What IPC basically is the formula to calculate IPC is I factorial divided by I minus C factorial. This, like, you guys can just look up some combinatorics scores or something if you want to know how this formula came up. So that's what you'll be calculating, and that you'll multiply that value with out. Okay, so that you'll be multiplying with out times equals this IPC value. Okay, so times equals IPC value would be the thing that you'll be getting. Okay, so this would be the thing for this size. Okay, and another, after getting this out, another thing that you need to consider is, suppose there are m elements. Okay, in this iteration you're picking I of them. Okay, so from this m, any I can be picked, any I elements can be picked. Okay, so suppose m is equal to 5 and I is equal to 3, you can have 1 2 3 3 4 5, or 3 2 5, any such combination can be picked up. So even that needs to be multiplied with out times equals out times equals this I, sorry, MCI. Okay, what this does is, so MCI is the number of ways to choose I elements from M. So that is multiplied with out. Okay, so this is basically what out would be storing. And this out, after computing this for each I, you would add it to the global variable total and output it. Okay, this would be the final answer. So yeah, total would be the final answer. Okay. So, okay, I think most people wouldn't have understood it, okay, because this involves quite, like, not very advanced, but some tricky application of combinatorics, and Combinatorics is a decently tricky topic for most people who are just starting out. To get used to these kinds of problems, just like apply combinatorics tag in code forces and solve all the problems that you get over there, probably in the range 1600 or so. Okay. So yeah, that is the solution for this problem. And the next problem that I was planning to do is a harder version of this, and I don't think it will be worth it. That's significantly harder than this. Like, even if you look at the solve count, that's 131, and this only has 31 solves, and that's significantly harder than this. I don't think it's worth doing it today. So you guys just try to look at the PCD again and look at the editorial for this problem once that comes up. And yeah, you will try to understand and maybe create a doubt if you want to ask me about it and ping me that. I'll try to clear you on the Discord server. Okay. So yeah, I think that, yeah, okay. So I think Brad had a doubt. Okay, Brad had a doubt about the third problem, I think. So yeah, feel free to unmute and ask.
Can
Yeah.
I ask now?
Yeah, ask. The harder version. Okay. So in the harder version, basically what they have given is they have already given some elements filled in the array. Okay, whichever position has 0, only those need to be dealt with in this. Only those can be freely filled with any number between 1 and n. It's similar to the previous problem, just that this extra array. So how do you deal with this case? Okay. Where is the whiteboard? Okay. So how to deal with this is basically what you'd have to do is one second. I'll just showcase my code and try to explain it. Okay, so this problem involves some in my solution, at least I had like an advanced data structure known as sparse table. I'm not sure if it's covered in the courses, but I think it would be like level 4 material, level 4 in the TLE Eliminators course. And what you would basically have to do for this thing is one basic thing is, suppose this the array has like n elements. Okay, suppose it has n elements. You need like the original thing that's given to you has like n non-zero elements. The output array will also have to have at least n non-zero elements. Like, that's quite obvious, I think, because you can't remove an element from the array. So it should have. So in the previous thing, we looped from 1 to min of n comma n plus 1 for the length of the permutation. In this, we'll do max of 1 comma size of the set till min of n comma m plus 1. Okay, so that's basically what you'd be looping from over here. And over here, for in that thing, we are choosing from m elements, we are choosing I. Since here st.size elements have already been picked, what you'd have to do is you do pick from m minus st.size, you will be picking I minus st.size elements. Okay, that would be the number of ways to pick elements, basically. And yeah, after that, what do you have? You have then what you're doing is from j to n, you're looping from j to n. Okay, so and j is equal to 1 is the first position up to till j is less than or equal to n, and j from to j you're adding I. Okay, plus equal to I, because the size of each permutation is I. So for each thing, the length of the permutation would be from j till j plus I minus 1. Okay, that would be the length of the permutation. Okay, so what this thing stores is query j comma min n comma j plus I minus 1 stores the index of the position. So this is a sparse table. Okay, so sparse table is a data structure which gives you like it takes O of n log n to build it, and you can find like minimum, maximum operators where if the ranges intersect, and while you're finding it, it wouldn't matter. So operations like that. So you can find those things in O of n. You can like building the sparse table will take O of n log n, and finding this will take O of n time. So That's basically, so what we are storing in the sparse table is, 1 second. So what we'll be storing in the sparse table is over here. Okay. So for each element, what we are doing is we are finding the previous position where this element again occurs. Okay, the earliest index where this element occurs. So that's the that thing you are finding it. Okay. So that's the so what you'll be doing is in this range you'll find for each element in this range, what is the earliest position, what is the latest position this element occurs other than this current position. Okay, in the previous last indexes, which is the earliest latest position where it occurs. Okay, that's the thing you are storing. So for that, from this range to in this pre-array, you're storing the index of the previous position where vector is present. Okay, so you're querying from j comma the last index of this range. You're querying that and seeing if that thing is greater than or equal to j. If that is greater than or equal to j, out is equal to 0. Why is out equal to 0? The reason why out is equal to 0 in this case is there are duplicate elements in that in this range. Okay, if there are duplicate elements, a permutation cannot have duplicate elements. A permutation should just permute a set of elements, and yeah, that's basically what a permutation is. So yeah, they cannot obviously have duplicate elements, and yeah, in that case, out is equal to 0, and you break out of it. So a permutation of length I cannot exist in this thing. Otherwise, what you're doing is you're so yeah, you're doing min n comma j plus I minus 1, because j plus I minus 1 is the general case. But since you are, suppose if you are towards the end, suppose you're in the last permutation, the permutation will not be complete. So j plus I minus 1 will exceed n. So you're just doing min of n comma j plus I minus 1 to make sure it is within that. And what you do over here is this is basically similar to what you're doing in the previous thing. You have I elements, but what you're doing over here is subtracting C and T min n comma j plus I minus 1 from this I. What this does is the number of elements which is fixed in this range. Okay, so if there are elements fixed in this range, you can't like place any new element over that. So you're subtracting them. Okay, so after you subtract them, you'll have like I elements in this range. I would be the length of this range, and I minus this thing will give you the number of ways to like place elements in this I minus this factorial will be the number of ways to permute elements in this range. Okay, that's basically what you'd have over here. And yeah, that would give you for this out. So you multiply that with out variable each time. This is similar to what we did over that. There we did binary exponentation. But one thing to notice is why this is not n square, and why this will pass within the time limit is each time you're adding I to j. You're not incrementing j by 1. So what this basically gives us, I'll just explain this with a whiteboard. So this is a classic like something that you would need to know to solve a lot of problems. I think this is the approximation with calculus. So each time what you're doing is you're when I is equal to 1, j would be incremented. J is equal to 1, 2, 3. So j, this will iterate n times. When I is equal to 2, j would be 1, 3, 5, and so on. And this, it will iterate n by 2 times. When I is equal to 3, it will similarly iterate n by 3 times. So it is going to be n plus n by 2, n by 1 plus n by 2 plus n by 3 plus so on. So this approximates to this gives you O of n log n. Okay, this is just this is something like you derive using calculus, I think. So this is something just it's generally useful to solve a lot of competitive programming problems. Okay, so this is something that's useful to know. And yeah, using this, what I'm doing here is instead of using binary exponentation like the previous case, even in the previous case, actually you could use this technique instead of using binary exponentation. Even this would work out on this consideration. So yeah, you're looping from you're adding I to j, and each time, as I described earlier, you're multiplying that thing over here. And in the case where j plus I minus 1 exceeds n, what you'd have to do is you'd only need like the length of the thing would be L. Okay, you will not have like I elements. Instead, you'll only have L elements, and C of them will you'd only need to place like C of them over there. So in that case, what I'm doing is, this is similar to what we did over there for the last case, for the remaining case, but with this extra addition of subtracting this from the things. So I'm subtracting that from this I over here, and also subtracting that from this thing. I'm subtracting that minus C and also subtracting C from that, which is like similar to what we did for the NPR, like NPR thing that I described when describing the easier version. So you'd compute out to be this, multiply this expression with out, and yeah, out would be this for this particular case, for this particular case, and you add it to tot like previously, and finally tot would be a final answer. So that's basically the way to solve the this problem. I'll link my code to in the description. So yeah. So that's basically the way to solve it. So should I end the recording? So
Yeah, you can stop the recording and end the meeting.
yeah, people. So stop recording. Okay. So if I stop it, it gets saved, right? It should be fine if I stop. Yeah. Okay.